Good afternoon, good evening.
Can people hear me? Just let me know if you can hear me. Brilliant. Okay, so just double check if the assignment has been published. We've changed the order slightly. Just double check. Very sorry, the assignment hasn't been published yet. So we've changed the assignment. The assignment is going to be on equations. And honestly, it's not a very difficult one because I've done the assignment myself, and yeah, it took me just maybe just under 2 hours to do the whole thing. It is about equations, different types of equations, particularly equations with square roots, equations with modulus, which are not very common in A levels, and equations with parameters. And of course, logarithmic equations as well. So I've prepared 11 questions for you, and once again, they're not very difficult. So you might find that this assignment is easier than the other than the rest. So kind of give you a break. The physics assignment is also ready, and it's going to be published in the next hopefully tomorrow. So I'm going to double check all of the assignment, solve all the problems, and we'll publish it. I would have published it, but unfortunately, I don't have access to the main page. It's only Alex has, so I don't know what's holding. Anyways, I'll share my screen. Okay, and please let me know if you can't see my screen for some reason. Otherwise, I assume you can see it. So the first equation, solve the equation modulus x minus 1 equals x minus 1. Well, how do you even approach this? How do you even approach this? It seems like it's very easy, and it is quite easy. But how do you start? Well, you might know the properties of the modulus. The modulus can either be the positive or negative. So that could be a starting point. But let's refer to the definition of the modulus. The definition of the modulus x, is equal to, now the square bracket means or, yeah. So the figure bracket means and this means or. So for example, if you write x is greater than 7 and x is less than 10, that means x can only be between 7 and 10. So this means x is less than 10 and greater than 7. But if you have or x is greater than 7 or x is less than 10, well, actually that's any number. That's all real numbers. Okay, is the distinction clear? Because any number is either greater than 7 or less than 10. Okay, is the distinction clear? And let me know if not. So if you write, I'll do another example. If you write x is less than 4 and x is greater than 6, this is impossible. It's not possible for a number to be less than 4 and greater than 6 at the same time. So this is equivalent to saying X belongs to an empty set. There are no numbers that satisfy this. On the other hand, if you write X is less than 4 or X is greater than 6, that means you have a set, all the numbers from -infinity to 4, and well, that's not and, that's united with all the numbers from 6 to +infinity. Okay, so this is just to explain the notation. So modulus X is either X if X is greater or equal to 0, or it is minus X when X is less than 0. That's one of the definitions of the modulus, and it's quite a powerful one. Quite a powerful one. So here, looking at X minus 1. X minus 1, using the same definition, is either X minus 1 if X minus 1 is positive, is non-negative, or it is minus X plus 1 if X minus 1 is negative. So this means that X is greater or equal to 1, and this means X is less than 1. So first, consider X is greater or equal to 1. If X is greater or equal to 1, then the equation becomes X minus 1 equals X minus 1, which is 0 equals 0, which is true for any X. For any X. But that's not the case, because we're not allowed all X's. We're only allowed the X's where X is greater than 1. So any X greater or equal to 1. 2, we're looking at X less than 1. And in this case, the equation becomes minus X plus 1 equals X minus 1. And the only solution of this equation is X equals 1, which does not belong to this region. So we write there are no solutions. X, it belongs to an empty set, no solutions. Okay, so we have the answer to this. The answer is X greater or equal to 1, and X is any real number. Any real number. Quite surprising that you have an equation, but the answer is a set of numbers rather than just a single value of X. Does it make sense on a scale of 1 to 10? How much sense does this make? You can also comment whether you find it easy or you find it challenging, whether it's something new for you or something you've already known. Yeah, you could have, of course, but then you would get. So look what happens if you do. If you square a modulus, the modulus kind of goes away. So you could have said, okay, x squared minus 2x plus 1 equals x squared minus 2x plus 1. They cancel out and you get x 0 equals 0. So x is any number. But that's not true. X is not any number, because this does not hold when x is negative. X is less than 1. Yeah, so the equation is true for any number from 1 and up. Okay. From the modulus. Okay. To clarify. So you have an equation, x minus 1 equals x minus 1. So we know that modulus x minus 1 is either x minus 1 when x is greater or equal to 1, or it is minus x plus 1 minus x plus 1 when x is less than 1. So assuming x is greater or equal to 1, then this modulus is this, and the equation becomes x minus 1 equals x minus 1. If you have this case, then the modulus becomes the opposite. So it's minus x plus 1 equals x minus 1. Does that clear things up? We'll do another example like this, so it will be clear, hopefully. So squaring both sides does not really work here, because you get you get many solutions that are not solutions. So for example, minus 3 is not a solution, even though minus 3 fits this. Yeah, if you take x equals minus 3, it will work. This is true for x equals minus 3, but the original equation is not. Therefore, yeah, squaring doesn't work here. In most cases, squaring works, but here it's not. And sometimes squaring is just awkward. Okay, if it's new for you, type new, please, in the chat. If it's something you already know, it's old for you. Type old. New. Okay, good. Okay, a couple of olds. That's good. Right. So here you have another equation which contains a modulus. So we're going to use the same principle to expand the modulus. So modulus of x plus 2 is either x plus 2 when x is greater or equal to minus 2. So when the thing in the modulus is positive, then it is we don't change the sign. If the number is negative, we change the sign. So minus x minus 2 if x is less than minus 2. Okay, so first case, x is greater or equal to minus 2. Also, in this assignment, we ask you to check your solutions. Like when you get the solutions, check them in the original equation. Now, obviously, you can't check for the first question. There are infinitely many solutions. You can't check them, so that's the only way to do them. The rest, yeah, they can be checked. They can be checked, and like honestly, a lot of the questions you will just swish through, as long as you get the ideas. But here I want to show a specific way of doing it. So you can assume that x is greater or equal to 2. That's our limitation. And that means that the equation becomes x cubed plus 8 equals 3x. And now just round brackets, x plus 2. Okay, so from here, we can factorize this. Is going to be x plus 2 multiplied by x squared minus 2x plus 4 equals 3x x plus 2. How did I do that? Well, there's a formula which is a very useful formula. Is the difference of two cubes, a cubed minus b cubed, sorry, plus b cubed can be factorized as a plus b, a squared minus ab plus b squared. A useful formula to remember. It works all the time. It's just like a difference of two squares, or square of the sum. So here you can see that you can divide both sides by x plus 2, but you're smart. You know that you are not allowed to divide by 0. So we have two options: either x plus 2 equals 0, and this equation is true, so it holds. So x equal to minus 2. So that's your first root because it satisfies this region. Or x is not equal to minus 2. And in this case, you are allowed to divide. And in this case, you write x squared minus 2x plus 4 equals 3x. X squared minus 5x plus 4 equals 0. So x2 is 1. x3 is 4. And both of these roots satisfy this inequality. So all three are valid roots. You can also double check them and actually insert them into the equation and check if they work, and they should work. Right, and now considering case 2. Case 2, x is less than minus 2. And in this case, the modulus of x plus 2 is this. So you write x cubed plus 8 equals minus 3x x plus 2. Now we do the same thing. So x plus 2 x squared minus 2x plus 4 equals minus 3x x plus 2. And now because x cannot be equal to minus 2, so this thing is not 0, so we are allowed to divide. We're allowed to divide. So we get x squared plus x plus 4 equals 0. And obviously this doesn't have solutions because the discriminant is negative, but I'm going to use a clever way of proving that this equation has no solutions. I'm going to do x squared plus x plus a quarter minus, plus 4 is 16 to 15 quarters. 15 quarters equals 0. So x plus a half squared plus 15 quarters equals 0. Now let's look at this expression. Well, we know that this expression is non-negative. So this is non-negative because it's a square. And this number is positive. So therefore, this equation has no solutions because this is a positive and this is a positive. Well, this is a non-negative technically. This is a positive number. So adding two positive numbers never gives you 0. Therefore, no solutions. X belongs to an empty set. So you have 3 solutions and they are here. 1, 2, and 3. Okay, so that's that. The next one. Well, it's the same principle. So I'm going to skim through it quickly. So first case, x is greater or equal to a half. Yeah, because this thing is equal to 0 when x is a half. So when x is greater than a half, this is positive. So it's going to be 4x squared minus 4x plus 2 equals 34 plus 4x. So 4x squared minus 8x minus 32 equals 0. So obviously this can be divided by 4, x squared minus 2x. 32 divided by 4 is 8 last time I checked, so it's 0. You can use the Vieta's theorem, or I'm a bit lazy to do Vieta's theorem, and I'm just going to do completing the square equals 9. So x is equal to 1 plus or minus 3. So x is 4, x is minus 2. So this, because we have this limitation on x, this is a valid solution. So this is a valid solution. This is x1, and this is not a valid solution because it's negative. It doesn't fit. So okay. Now consider the second case. The second case, x is less than a half, and we get 4x squared plus 4x minus 2 plus 4x minus 2 equals 34 plus 4x. 4x cancels, and we get 4x squared equals 36. X squared equals 9. X is plus or minus 3. Now, once again, we look at the limitation. The limitation is x has to be less than a half, so x is minus 3. x2 is minus 3. So these are the two roots of the equation. Obviously, and what it's a matter of choice. There is an agreement between mathematicians that we put greater or equal with the positive case, but obviously it can be put as into the negative case, or it can even be put separately. Like nobody, you can always say that modulus x is equal to either x when x is positive. Sorry, I'm using this figure bracket. It's minus x when x is negative, or it's 0 when x is 0. Yeah, you can do triple scenario, but it's a matter of choice. You could do it either way. Most mathematicians just say it's more comfortable doing, more convenient, using with the positive case. Okay, so this is another one. Now here you have a square root. Whenever you have a square root, you have to put limitations on what's under the square root. The number under the square root cannot be negative. So we have to write, just before we do anything, we write x plus 2 is greater or equal to 0. So x has to be greater or equal to negative 2. So with whatever answer you get, it cannot be less than negative 2. Now, this expression also has to be non-negative. X cubed plus x plus minus 1 is greater or equal to 0. Now, I could solve the inequality and see which x's I'm allowed to use, which are not. But it's too complicated. I honestly, I want to avoid doing this. I want to avoid doing this yeah, avoid doing. Oh, actually, no, that's I was wrong. I made a mistake here. Okay. Yeah. So my initial idea was that x is greater than 2, not minus 2. And in this case, this is positive. I'm not going to solve this, but I just keep this in mind. Keep in mind. Keep in mind. Because is it actually possible to solve? Definitely is. But yeah, I'm just going to keep this in mind because it's too difficult to solve. This is easy. This is difficult. So, and now I'm going to solve it. So I have two expressions. When they multiply, they make 0. So one of the expressions is 0. So it's either x squared minus 9 equals 0, or this thing is equal to 0, or square root of x cubed plus x minus 1 minus square root of x plus 2 is 0. So this is easy. X is equal to plus or minus 3. Although, remember that we have a limitation. X cannot be less than -2. So x is equal to 3. Check that this works. Well, 3 cubed plus 3 minus 1 is definitely positive. So this is fine. Like, we are allowed. This is a valid answer because it satisfies this inequality. So this is one of the answers. We'll call it x1. Now this one. Well, I take this to the right hand side and square it. X cubed plus x minus 1 is equal to x plus 2. So we've squared it. Now, because they are equal, they are both going to be positive or both going to be negative at the same time. And we know that this thing is positive when x is greater than -2. So we have only one limitation here. X is greater or equal to -2. So we don't even need to consider that this is positive, because if x is greater than -2, this is going to be positive, and if they are equal, this will also be positive. So this is a little bit of a shortcut here. So we get x cubed equals 3. X is equal to cube root of 3, and it's obviously greater than -2. You can check it. You can check it in the original equation, and it will work. If you do, so do please check. In this assignment, we ask you to explicitly check that they work. Do they work? Do they work? It's called a sanity check. Right. Okay, next one. It's a mixture of modulus and square roots. So what we know is that x is greater or equal to -2, because this has you cannot take a square root of a negative number. That's your global limitation on x. I was looking for a special word in English that describes that, but I haven't found it. Like the allowed values of x, the region of allowed values. Well, anyways, so we have two scenarios. So first, x is greater or equal to 1. And in this case, the equation becomes square root of x plus 2 equals x minus 1. You square both sides. X plus 2 is equal to x squared minus 2x plus 1. Not, yeah, no, this is the absolute value. No, this bit, this is a limitation on X. This is, I'd like to say, okay, Chernoff defines it as domain of the equation. Domain of the equation. This is my definition. I haven't found anyone using it. That's how I'd like to call it, domain of the equation. The possible values of feasible region. Yeah, that sounds very good. A feasible region. I don't know if it's widely used. So x squared minus 3x minus 1 is equal to 0. So this the solutions of that is 3x is 3 plus or minus root 13 on 2 over 2. And okay, so that's the first case. Now we're looking at the second case. X is less than 1. And that means that the square root of x plus 2, well, x is less than 1, but it also has to be greater than minus 2, greater or equal to minus 2. That's the global limitation on x. X equals minus x plus 1. So we square it, and when we square it, we actually get the same equation. X squared minus 2x plus 1. And we get the same equation, and x is equal to 3 plus or minus square root of 13 on 2. And from here, because x is greater than 1, there's only one solution possible. X is 3 plus square root of 13 on 2. And for the second one, because it has to be less than 1, that means the only possible solution is the minus. So 3 minus square root of 13 on 2. It looks like we've made our job harder. Rather than just squaring it and finding the two answers, we went a long way to arrive to the same two answers. But squaring very often leads to extraneous solutions, which have to be eliminated. So an easier way to do this particular question would be just to square both sides, find the answers, and check the answers in the equation. The only problem is the numbers are not easy to check. If it's a non-calculator paper, it's not that easy to check those answers. So that's one of the reasons why we would use this method rather than just squaring. Okay, getting to the interesting tasks. So this one is probably the hardest problem of the set. And it says find all values of a for which the equation has exactly one root. Wow. Okay, so what can we do? Well, first of all, I'm going to split it into two parts, split it differently. So I'm going to use this 5 minus 4x minus x squared and equals to minus ax plus 3a plus 3. Well, this looks like an equation of some curve. And this looks like the equation of a straight line. So that's what I'm going to do. I'm going to say that this is y equals square root of 5 minus 4x minus x squared. But I have to keep in mind that y has to be positive. because the square root cannot take negative values. So I'm just going to take this. This is an and because they have to be true at the same time. And here, y is equal to minus ax plus 3a plus 3. And I'm going to sketch those. I'm going to sketch those curves because that's the easiest way to analyze whether how many roots it has. So what can I do here? Well, obviously there is software you can use, such as Desmos, which really helps in those questions. The problem is that sometimes you won't. For example, if you're going to do the PAT test, you don't have the Desmos calculator with you. Anyways, so I'm going to start with the first one. The first one is easier, even though it looks harder, it's actually easier. So I'm going to square both sides. So it's a y squared equals 5 minus 4x minus x squared. And actually, y squared plus x squared plus 4x equals 5. Can somebody recognize what shape is it? Does anyone see it already? Of course, it is a circle. It is a circle, so it's x plus 2 squared plus y squared. Now we've taken the 4, so it's going to be 9. So it's a circle, center minus 2, center minus 2, 0, minus 2, 0, and the radius is 3. So it's a circle like this. Okay, so this is minus 2, this is 1, this is minus 5. It's exactly one root. So that's a circle, but remember, you have to remember that y has to be positive. You're not allowed negative values. So it's a half circle. It's a circle, but only like this. It's a half circle. Now let's analyze this. Well, let's do, well, there are different ways to approach this. Let's say if a is 0. If a is 0, y is 3. That's easy. That's a horizontal line. So y is 3. Oh, as a matter of fact, if y is 3, it has exactly one solution because it's a one point of intersection of the circle with the line. So a equals 0. A equals 0. What happens if a equals 1? If a equals 1, y is minus x plus 6. Okay. Minus x plus 6, so you can sketch that. So it goes through here. Almost. So this is a equals 1. Equals 1. Let's see if we can notice any patterns here. Let's make a equals 2. Y is going to be minus 2 plus 9x, well, plus 9, sorry, minus 2x plus 9. And we can sketch that. oh, it seems like all the lines for different A's go through the same point, and A is the negative gradient of that line. So all the this line for different values of A always goes through this point, 3, 3, and A is the negative gradient of that line. Is that clear? Is that, do you see that? A is the negative of the gradient, and it is the negative of the gradient. It's just how to prove that it goes through that point. Well, you can write it as y equals minus a x minus 3 plus 3. So you can see it's a straight line which is shifted to the right by 3 and up by 3. So it has to go through the point, and A is the gradient. Make sense? A is negative A is the gradient. And 3, 3. 3, 3 is a point, it belongs to the line. Belongs to the line. So some feedback. Yes or no? Clear? Not clear? Confused? Clear. Okay. And obviously, you just need to find the value of the gradient for which there's only one solution. One solution. Well, we can see that if the line goes like this, it has exactly one solution. And anything up to here, it has exactly one solution. So if this is true, then the gradient is, well, it's very easy to find the gradient of that line because it goes between these 2 points. So the gradient is 3 minus, the gradient of the line is 3 over 2. So A is minus 3 over 2. If it goes like this, the gradient is, so 3 and 3, 3, 8. So 3/8. A is minus 3/8. Minus 3/8. 0.33 belongs to the line, is on the line. And then if it's between 0 and minus 3/8, it's going to be 2 solutions, 2 points of intersection. So the solution is one solution, and if A okay, it's not working. One solution if, and I'm going to use my new notation, which I'm using in this session. One solution if A is equal to 0, because you can see only one point of intersection here. And if A is greater than minus 3 over 2, greater or equal to minus 3 over 2, because that's this case, case. That's clearly one point of intersection here. And it has to be less than -3/8. -3/8. And yeah, that's it. This is one of the ways how you approach equations with modulus. Now, if I were doing, so this is how we always did it. This is in the old times, because there was no technology available. Now, how would I approach this question nowadays? Well, I would use Desmos. Yeah, if I was doing it at home, I would do Desmos. Desmos is just amazing in doing this. So what do? We say, well, we split it the same way. Y equals square root of 5 minus 4x minus x squared. That's our semicircle. And y is equal to minus ax plus 3a plus 3. And you click add slider for a. And we need a bit. So let's do it from -5 to 5. And then don't put this step. And okay, so let's see what happens. So if a is positive, well, there's no solutions, no solutions, no solutions, no solutions, no solutions, no solutions, no solutions. And then bam, solution. That's a equals 0. That's one solution, because one point of intersection. You go to, that's 2 points of intersection. That's no good. Then you get to a point where it's still two solutions. Now it's only one solution. One solution, one solution, one solution, one solution. Still one solution. And then 0 solutions. Okay, so you can see how the line changes when a changes. And you need 2 points of intersection, 1 point of intersection. Okay. We can write it. They're not asking us, but we can say that it's two solutions. Solutions if between if a is less than 0 and greater or equal to -3/8, and 0 solutions if a is less than 0. No, a is greater than 0, sorry. It is greater than 0, or a is less than -3/2. Yeah, so then there are no solutions. Sometimes they might ask you for this, but usually they want something in particular. Why could a be equal to why? No, it can't. Oh, it can't. I'm sorry, my bad. It has two solutions if -3/8. Thank you. Problem 7. So you have this square root thingy. Well, it's quite hard to find the allowed regions here. Well, obviously, first of all, you have to say that 4x cubed minus 5x plus 1 has to be greater or equal to 0 because it's under the square root. But then this root has to be has to be positive as well. So it has to be less than 1 as well. So you're within these limits, but like solving this inequality is tough. You will have some inequalities in the next assignment, in assignment 8. But when it's not an easy task to do, especially when that's not the main purpose of what you're going to do. So what you're going to do is you're going to check whether your answers fit this description. Let's see if there are any other limitations. Well, actually, no. Like this has to be positive, yes. This root has to be positive, yes. But otherwise, it's fine. It's fine. So what you're doing, you're squaring both sides. There's no surprises here. Minus square root of 4x cubed minus 5x plus 1. You can also make your life easier by using a substitution, for example. Yeah, let's do it. Let's do a substitution. So it's going to be 1 minus square root of u square root equals square root of 1 plus square root of u. And obviously, you know that u has to be positive, greater or equal to 0, but also u cannot be 1, because if u is greater than 1, then this thing is going to be negative. So it's less than or equal to 1. Okay, so you square both sides, it's going to 1 minus square root u equals 1 plus square root u. 1 cancels, you get 2 square root u equals 0. So square root u equals 0, u equals 0. Does that satisfy this? Well, yes, u can be 0, so there's no problems with that. And all we need to do is reverse substitute. So you got 4x cubed minus 5x plus 1 equals 0. I hope you know polynomials. So you're trying to guess a solution. And my guess is 1. Yeah, if I substitute 1 into the equation, x equals 1 is a root. Very simple, because 4 minus 5 plus 1 is 0. So I'm going to try to isolate this. I'm going to use 4. So I'm looking to divide by x minus 1. Yeah, so it's 4x cubed minus 4x squared plus 4x squared, because I have to 0 that. 4x squared minus, now I have minus 5x, but I need 4x, obviously, minus 4x, and I'm left with minus x plus 1. I'm gonna take minus x minus 1 like this, equals 0. Then I factorize the three terms, so 4x squared x minus 1 plus 4x x minus 1. This is an alternative to dividing, to long division. Type F, please, if you're familiar with this method. This is an alternative to long division. And you get 4x squared plus 4x minus 1 equals 0. If you're familiar with this method, type F in the chat, please. No? Can you still hear me? Not really. Okay. So no Fs. Okay, I see. No Fs because you're not familiar. Okay. If that is correct assessment. So what am I doing here is I'm splitting I know that x minus 1 has to be a factor because x1 is a root. So I make it a factor. I group the terms in such a way that x minus 1 is a factor, because you can clearly see that this expression and this is equivalent. So what I do here, I literally just write down 4x cubed minus 4x squared plus 4x squared minus 4x minus x plus 1. See, I haven't done anything. I mean, I've only changed, I've only regrouped them. And there's 4x cubed, this cancels, this is minus 5x, so plus 1, so it's the same thing. But now if I group them like this, I can factorize. I can take x minus 1 out of the brackets. And that's I like this method. I find long division a bit tedious personally. This is just relaxing for the brain. I don't know. That's me. Do you understand the method type on a scale of 1 to 10? Do you understand the method? Okay. Maybe some comments on whether you would be comfortable on using it. You can use it for simple ones as well. So x squared minus 4x. Okay, that's too easy. Plus 3. Yeah, why not? X, you can factorize this because you can clearly see that 1 is a root. So it's going to be x squared minus x. You're left with, so minus x, you still have minus 3x to go, plus 3, and that is x minus 1, minus 3, x minus 1. Obviously, you wouldn't use this method for a quadratic, but why not? 3, x minus 1. It's another tool. The AC method, it might be. I have never heard of it having a name. I think it's just called by grouping. Yeah, the factorization by grouping. Anyways, you have x equals 1. X equals 1. That's the first root. Does it fit this? Well, it obviously does, because when x is 1, this thing is 0, and it can be 0. So x equals 1, and this thing, well, it's well, let's do it properly. I mean, I know you all can do quadratics, but maybe you learn something new when you see how I do quadratics. So I'm doing completing the square plus 4x plus 1. And this has to be equal to 2. So this thing is equal to 0. I change this to plus 1, so this becomes 2. So I'm adding 2 to both sides if you wish. So it's going to be 2x plus 1 squared equals to 2. So 2x plus 1 is equal to plus or minus square root 2. It seems suspicious. Oh no, it's perfectly fine. So from here, I get x is equal to minus 1 plus or minus root 2 divided by 2. Perfect. So in both solutions are valid. Both solutions are valid. It's easy to check because all three solutions are valid, because if you substitute them into the original one, this thing would be 0, and square root of 0 is 0. So 1 minus 0 is equal to 1 plus 0. That's, yeah. Okay, so sanity check. I'll just remind you that you have to do a sanity check. Sanity check. Substitute sub into the original equation. Okay. So how many do we have? Yeah, I think we have just enough questions for half an hour. Find all values of a for which the equation has exactly 2 roots. Well, another question with the parameter. So x squared minus 6 modulus x plus 6 equals a. Just to separate them. And it seems like this is a reasonable thing to actually draw. Let's see if we can do something to it. Well, we can say that x squared minus 6x, so complete the square, plus 9 minus 3. That's a completed square, equals a. And it's going to be, well, we know that modulus x, sorry. One important thing here is that modulus x squared is the same as x squared. You can check that for yourself. You can check that for yourself because, well, this is true. This is a non-negative value and this is a non-negative value. So, and because of this, I can write modulus x squared minus 6 modulus x. You'll see why I'm doing this, plus 9 minus 3 equals a. And here I just, yeah, it's going to be modulus x minus 3 squared and minus 3 equals a. So what is this? Well, this is a graph, and it's actually very easy to draw it. So we start with y equals x squared. Then we transform it to y is equal to x minus 3 squared. That's a horizontal translation. And minus 3, that's a vertical translation. So it's a parabola. We shift it to the right. Sorry, we shift it to the right. Oh, I don't know how you see me. Is it mirrored or not? It's like this, and then it's shifted downwards. And then the next transformation is modulus x, the modulus x transformation. If you're not familiar with the modulus x transformation, minus 3. So what do? We say, okay, I'm just going to show it on Desmos. So we have y equals x squared. Well, yeah, you all know how this looks like. Now y is equal to x minus 3 squared. That's a shift to the right. And I'm going to do down on the same one, so minus 3. So that's a shift to the right and shift down. Now, what does the modulus x transformation do? Can somebody help me? If we take x to the modulus, so if in any, okay, if we get any equation, so y is equal to e to the power of x, okay, 0.02x multiplied by sine x. Okay, so let's look at this graph. So you can see that it's a sine wave, which is getting bigger, bigger, and bigger. It's a sine wave multiplied by an exponent. So that's quite an interesting graph, actually. I'm going to increase the frequency, so 100. Okay, 10x. That looks quite interesting. So it's a sine wave, then the amplitude is an exponent. All right. So what happens if I put a modulus? If I take the same thing and put a modulus here. Can somebody help me? What happens? Anyone? If I do the modulus transformation, what happens is the right side of the equation is unchanged. Look, the right side is unchanged. But the left side is copied from the right-hand side. The right side of the graph is mirrored on the left. This is what the modulus transformation does. So it is we start with f of x, then we do f of x minus 3, and then we do f of modulus x minus 3. So what it does, it mirrors the right-hand side of the graph onto the left, and therefore, if we have this graph, if we mirror the right-hand side on the left, we're going to have two parabolas, two kind of semi-parabolas. So if I do modulus x here, this is what I get, the upside down McDonald's sign. And then, so it's, yeah, so we can plot that. We can plot that graph. And this is 6. This is -3, -3, -3, -3. So go like this. Okay, so this is y is equal to modulus x minus 3 squared minus 3. And now we need the second graph, but the second graph is very easy. It's y equals a. So this is y equals that, and the y equals a. And y equals a is a horizontal line. So this is, for example, when y is a, when a is equal to -6. So this is y a equals -3. This is another critical value where a is 6, A is 6. Anything above 6. So the answer, so the question was, for which values of a does it have exactly 2 roots? It has exactly 2 roots when a is -3. Answer, 2 roots when a is -3, or a is greater than 6. Okay, so if we have, and we can confirm that here. So this is the graph, y equals a. X add slider a. And you can see that as a changes, the line changes. So this is a equals -3. And this is a equals 6 and more than 6. So it's either a is -3 or greater than 6. Okay, this is another one. Here you would use substitution. You would use substitution, and you have u is equal to ln x, and v. Okay, it's not a good idea. I'm gonna use v and w, or double v, w. V is ln x, and w is log x. And I'll rewrite the equation. So vw minus 2 equals log, so w minus 2v. Right. What can I do here? Well, I'm going to change the way they go. So I'm gonna take them all to the left hand side. So vw minus 2 plus 2v minus w. Well, now I can group them. I can group this with this and this with this. So I get w v minus 1. And here they have the common factor, which is 2 v minus 1. Ah, interesting. So I get v minus 1 multiplied by w plus 2 equals 0. So it's either v equals 1 or w equals minus 2, which is equivalent to, well, this is not the equivalent. The equivalent is like this, which is equivalent to ln x equals 1 or log x equals minus 2. So x is e, because ln e is 1, and x is 10 to the power minus 2, which is 0.01. Okay, that's the answer. That's the two answers. Well, you can definitely do perform a sanity check, but there's only one limitation, that x has to be positive, because you cannot take a logarithm of a negative number. Therefore, x is greater than 0, and they're both greater than 0, so that fits. Okay, problem 10. Now, this question is way easier than it looks, because if you actually try solving it, you're gonna have a bad time. I mean, I can't even see where you would start. But can we guess? Can we guess a solution? Yeah, absolutely. X equals 1. X equals 1 is a solution. How do we know, or can we know, that there aren't any more solutions? How can we know that there are no more solutions? Well, this is very much related to the previous assignment, the one that was due on Sunday. We need to know the properties. What do you know about these two functions? What do you know about f, let's say, is 2/5 x, 2/5 to the power of x, and g is 3/5 to the power of x? Any properties? How do they look like? Are they positive, negative? Anything? Just tell me everything you know about these two. They slope backwards, and that's incredibly important. They both slope backwards, so their sum of the two functions will also slope backwards. So both functions slope backwards. Slope downwards. I think that's the word, not backwards, but you can say slope. Yeah. Anyways, it depends on how you look at it. They slope downwards. I'd rather say they slope downwards. So that means the total of the two functions also slopes downwards. And it's very easy to confirm. Basically, what that means, so if you take a function, well, I've used f and g, so if h of x is 2/5 x plus 3/5 x is a downward sloping function. In other words, it's a monotonic function. That means if x2 is greater than x1, that necessarily means that f of x2 is less than f of x1. Yeah, and just to show that on a graph, the function is sloping backwards. If this is x1 and this is x2, f of x1, 1, and is going to be less than greater than f of x2. This is what it means. So this is a downward sloping function, or a monotonically decreasing function. So we write h of x is equal to 2/5. Why am I doing this? Is a monotonically decreasing function. Like all monotonic functions are one-to-one. Not all one-to-one functions are monotonic. I'll clarify this. It's a monotonically decreasing function, so it's sloping downwards. And the right-hand side is 1. It's a constant, so it's a horizontal line. It's monotonically, the graph is sloping downwards, and this is a horizontal line. So a horizontal line and a downward sloping function can only have one point of intersection, and we found it. It's 1. A sloping downwards, a sloping downwards graph, and a horizontal line can only have one point of intersection. I mean, in this particular scenario, it was very easy to guess 1. Now, if it's not easy to guess, you can use trial and error. You can use the Newton-Raphson method or any numerical method that allows you to arrive to the solution. The problem was proving that there's only 1, and there can only be 1 because 1 is a sloping downwards function, 1 is a horizontal line. And if you want to confirm it, do it on Desmos. So look, monotonic and one-to-one functions. Let's make a note: monotonic versus one-to-one functions. Let's see. Well, all monotonic functions are one-to-one because the way they are. So this is a monotonic function, and so it's a monotonically increasing function. This is a monotonically decreasing function. So they are one-to-one, obviously, and you can see that from the graph. However, if the function is not continuous, for example, a function like this. Like this, and like this. So this is a one-to-one function, technically, yeah, because each value of x corresponds to exactly one value of y. So if you know x, you know y. Oh, okay, not quite, but I'll shift them a little bit like this, just to be clear. If you know the value of x, you know the value of y. I mean, this is a bit far-fetched example, but it works. This is a one-to-one function, but it's definitely not monotonic, because for monotonic means that if you monotonically increasing, for greater x's you get bigger y's, and for monotonically decreasing means for greater x's you get smaller y's. But this is a one-to-one function, but it's not monotonic. Does that make sense, Edward? But you can safely say any continuous one-to-one function is a monotonic function. Any continuous owes a one-to-one function. Is monotonic. Is strictly monotonic. Does the difference make sense, guys? Okay. So just to be clear, so here you have x1, and here you have x2, and here you have x3, and you see that x2 is greater than x1, but y2 is smaller than y1. But for this pair of values, x3 is greater than x2, but y3 is greater than y2. So it's not increasing and it's not an increasing function and not a decreasing function. So it is not monotonic, but it is a piecewise function. Right. The last question is also a question of the parameter, but actually it's an easy one. It's an easy one. So we know for which values of a does the equation have solutions. Well, we know that the base of the logarithm cannot be negative. So we write this: a is greater than 0. Also, we know that the base of the logarithm cannot be equal to 1. So we know that a is not equal to 1. Also, we know that the logarithmic expression has to be positive. So x minus 2a has to be positive. In other words, x has to be greater than 2a. Okay, so these are our limitations or domain of the equations. Now, let's actually solve the equation and see what we get. So log a x minus 2a, and 1 can be written as log a from a, log a base a. So the logarithm is a monotonic function. That means that this has to be equal to this. X minus 2a has to equal to a. So x is 3a. But a is positive, so we know that. That means x is positive. Okay. And x is 3a, and 3a is definitely bigger than 2a. So this solution, this only solution, satisfies this limitation. Satisfies this because a is positive. Therefore, it always has a solution if a is valid. There is always a solution. There is always. So this is a solution shown if a is valid. If a is valid, because once again that this is greater than 2a, because a is positive, that means this is true. So the answer is simple. Answer: a is greater than 0 and a is not equal to 1. And that's it. Wow, and that's exactly an hour and a half. My timings are getting better. Any questions? Any questions? Anything you'd like to ask, to go through maybe in the next
Yeah. Could I ask something?
Yeah.
You know, when you had the graph and you deduced the gradient, where you had that half circle.
Yeah.
Yeah. I was just I got the rest of the question. The only part that I didn't get was how you deduce that when you had the straight line. How do you deduce the equation of it? That it had to be 3-3. It had to go through 3-3.
Oh, I just started drawing lines for different values of a, and I saw a pattern. So I I took a equals 0 and I drew the line. I took a equals 1, I drew the line. I took a equals 2, I drew the line, and I saw that they all go through 3, 3. And obviously a is the gradient, so that helps. So if the line goes through 3, 3 regardless, and a is the gradient, I can work with the rest. Does that make sense?
So did you just find 3, 3 by observation, and then you knew that A
Yes,
was
I did it by observation. But if you want to do it not by observation, then you write down the equation like this. So what is this? What is this equation? Well, this is a series of transformations of the graph. So you guess you start with y equals x graph. Then you stretch it vertically. So y is minus ax. So this is a vertical stretch. Then you have a horizontal shift equals minus a x minus 3. That's a horizontal shift. And then there's a vertical shift, which is plus 3. Okay. Are you familiar with the graph transformation?
Yeah. Yes, through it.
And
To the
this,
right.
so if it's a straight line that is shifted by 3 to the right and 3 up, that means it is it goes through 3, 3. But this is way more difficult to see rather than just draw the line and see that, oh, whatever a is, it goes through that point.
Oh, so just like y equals minus ax always goes through 0, 0, therefore y equals minus ax minus 3 plus 3 always has to go through 3, 3.
Yeah, of
Because
course.
of the same logic. Oh, I see. Yeah, I get it now. Yeah.
Okay.
Thank you.
You're welcome. Right. Anyone else? Okay, well, then I'll see you next week, and we'll do physics next week. And the physics will be DC circuits, so electricity. So I hope you remember the topic from the beginning of year 12 or middle of year 12 or now. Okay, all right, see you.